Assalamualaikum warahmatullahi wabarakatuh. My name is ASHIKA binti MARZAIRI and I am a student from Mathematics 3. This is my continuous assessment presentation. Here's some things about me. My full name is ASHIKA binti MARZAIRI. My age is 18 years old. I am currently studying in Institut Pendidikan Guru, Campus Kota Baru. I'm born and raised in Perlis. I have two younger siblings, which I am the first child. And my favorite subjects in school is mathematics. Okay, so here are some overview of the topics that I'm gonna discuss in my continuous assessment test 2, which is the basics of quadratic equation, linear equation, the implications of both of them in archery sport. We'll go to quadratic equation first. Okay, so the definition of the quadratic equation is the polynomial equation of the second degree, meaning the highest power of the variable is 2. So we can conclude that quadratic equation is when the equation has x squared, meaning the highest degree, the highest polynomial equation of the second degree is to the power of 2. Here's the standard form of the quadratic equation. As you can see here is ax squared plus bx plus c, where the x represents the variables and the abc is the coefficients, where they need to be constant. You may wonder, right? What does a, b, and c mean?
What does A, B, and C represent?
So now I'm gonna break down and explain to you what A, B, and C each represent. First, we'll get to coefficient A, which will determine the shape of our graph. So when your A is positive numbers, such as Amsha, can you give an example of number positive?
2.
Yes, correct. So when you get let's say like your A is 2, so then your graph will be like this. But if your A is a negative number, let's say like -2, then it will be like this. So to conclude, this is like when you're positive, your graph will smile like this. And then if it's negative, your graph will be sad. Now I'm gonna need Amsha to guess which of the graph has the A value 8 and 1. So which one of this is 1 and 8? Cuba teka.
A.
Yeah, teka A dulu. Like, what do you think the value of A for this is?
Oh, probably
1 or 8?
1.
1.
Yeah.
Correct. Yay. So yeah, to conclude this, like when you see this graph, it's like the arc is very lebar, while the B is very narrow. The graph is very narrow, while the A is a bit wide. So that means the value of A for this graph A is 1, while the B is 8. So it means that as the more positive your graph is, it will become more narrower. Now we'll get to coefficient B affects the position of the parabola's axis of symmetry, which means it's shifting the parabola horizontally and changing the slope as well. I'm gonna show you a video for how to find the B.
The graph shifts to the left.
Yo, see? When your value of B increase, it will go slow down to the left of the graph, which to the negative x. And so as you can see, when your value B increases, your x-axis will come to the negative side of the x-axis here, you see. So your axis of symmetry, sorry, I was meant to say axis of symmetry. As you can see, your axis of symmetry is at the left side of the graph, which is more inclined to the negative value of your x-axis.
The graph shifts to the right. Again, the opposite direction of what may feel intuitive.
Yeah.
The more B.
So, as you can see, when your value of B is negative, it will shift to the positive side of the x-axis. So it's like the opposite. When your B is negative, your graph will shift to the positive side of the x-axis graph. Okay, now we'll go to the explanation of C, which is the y-intercept. Okay. So the coefficient C affects the y-intercept of the graph. So as you can see here, when you have the equation x squared plus 5x plus 3, your C is this 3 right here. And when you look at the graph, the point where it intersects the y-axis lands on 3, as you can see. So this is how to find the roots, which is the solutions of the quadratic equation, which will have 2 solutions every quadratic equation because it touches 2 points on the x-axis, which we also call as roots. As you can see in this graph, I put there's these 2 points which the graph touches at the x-axis, which means it intersects at the coordinate -2 and 0 and 2 and 0. So here's some of the ways to solve quadratic equations and by finding the roots by the equation that is given. Okay. So we'll get to factorization methods, which is I wrote a keyword right here, which is to break down the equation. This is not our quadratic equation. This is just a normal equation to see like the example. Okay, so we have here 4x plus 32, which when we will break down, we'll get 4 in brackets x plus 8. When we expand this, what will we get? So now we'll get to the factorization methods, which I put the keyword here is to break down. The equation here is not a quadratic equation. It's more like linear equation, as you can see. So the way to break down this equation is by segregating or separating the value into a brackets. So as you can see, this 4x plus 32 is equal to 4 in brackets x plus 8, which when you expand this 4x, 4 times x, you get 4x, and 4 times 8, you'll get 32. Because go back, please go back. Okay, as you can see, the reason why your y needs to be 0 is so that we can find the value of these 2 roots. Okay, so we'll get to the factorization methods. As you can see, this equation x squared minus 10x plus 16 equal to 0, which the value is initially y, but we'll put the y to be 0.
Why does the y need to be 0?
That's a great question. So can we go back to slide beforehand? Okay, so for the example, as you can see, where the 2 coordinates, or as you can say, roots, are touching the x-axis instead of being above the x-axis, which means your y is 0 because it intersects your x. We'll go back to the previous one. As you can see, I put this x minus 8 and x minus 2. The way you can find this is by putting these equations into your calculator, which you'll get x equal 8 and x equal 2, which means your roots, or the 2 points that intersect, the 2 points that is touching your x-axis is at x equal 8 and x equal 2. Here's an example of where the points are touching when you put the equation x squared minus 10x plus 16. Okay, next. Now we'll get to quadratic formula, and here's the equation x is equal to negative b plus minus b squared minus 4ac divided by 2a. This quadratic formula, I can say, is like more inclusive than factorization method, because the factorization methods are some of them we cannot use factorization methods, but with quadratic formula, it's more, we can use it in any situations of your quadratic equations. So given is 2x squared plus 3x minus 2, which as you can see, your a, the value for the a is 2, b is equal to 3, and c is equal to -2. So you can just put the value of a, b, c in the quadratic equations, as you can see, and then you'll get to the value x, and then you'll get to the value is x is equal 1/2 and x is equal -2. First of all, has any of you familiar with the linear equation?
What is the linear equation?
Well, great question. So, I can conclude that the linear equation is the straight line that is laid on a specific graph or plane. Wait, no. Let me give you an example. Let me give you an example of the linear equation. As you can see, is a straight line on a plane. How do you write the equations of the straight line? As you can see, that you can write it in the form of y equal mx plus c, or ax plus by equals c, or y1 minus y2 equal m and x1 minus x2. So if you're wondering, for these third equations right here, is specifically to find the value of the gradient, which is m, which I'll explain later. But the y1 and y2 and x1 and x2 is a specific coordinates that lays on the straight line. So I'll explain to you this equation first, which is y equal mx plus c. So do you know what the m and the x means?
M represent the gradients, C represent the y-intercept.
Yes, great. So you already know, like, right, what the y-intercept means. Yeah, okay.
It's the intersecting of lines.
Yeah, it is when the graph is intersect with the y-axis. Okay. Next, so when your gradient is positive numbers, such as like 1, 2, 4 or 3, you'll get your positive gradient like this. So it's when your value of the x-axis goes from negative go to positive on your x-axis. Well, as you can see, is when your gradient is a negative, you can see that, when your gradient is a negative, you can see that your slope will be from atas to bawah, from top to bottom. When you're given two coordinates, which the coordinate lies on top of your linear equations, you'll get whatever coordinate and whatever coordinate, which I'll just put here for now is x and y, and x1 and y1. So as we had the equations earlier, we can find the gradients or the slope or the keturunan of the graph in the equation coordinate y of first coordinate minus coordinate y of the second coordinate divided by the coordinate of the x of your first coordinate and your second coordinate for x. So now we'll get to the discussions regarding the implication of your quadratic equations and linear equation in the form of archery sports. Okay, so for the introductions, archery, while relying on skills and consistency, is connected by the physics of the projectile motions. To consistently hit a target, an archer must subconsciously or consciously compensate for the arrow trajectory, which is a perfect parabolic curve. So like, okay, I'm sure. Can you give like an example of like how the arrow travels when the arrow of the archer is released?
Like this?
Yes, correct. Well, yes, that's correct. As you can see, is when you're doing the archery sports, you'll usually aim your arrows a bit slightly high up. That's because the gravitational pull will pull your arrow downwards. So it means you need to shoot your arrow a bit slightly higher up. So then it will form a parabolic curve, which is this. Right now, it will form a parabolic curve, which is a quadratic equation. As you can see, it's like, ooh. Okay, I'll write here. To predict an arrow's flight path, we focus on the implications of the linear equations, where we'll use the linear equations to find the distance, and we'll use the quadratic equations to find the height and time. Wait, no. To find the height and the time taken for the arrow to hit the target and the ground. The horizontal motions, which remain constant and is modeled by a linear equation. The vertical motion, which is subject to gravitational acceleration and is precise modeled by a quadratic equation. Okay, next. So here's the problem statement. It is given that for trajectory of an arrow traveled from an archer to the target, assume the height of the archer and the target is the same, which is 1.5 meters. Next. So solve the equations by finding the time of flight using quadratic equations. Calculate the total time the arrow spends on the times the arrow spends in the air before it strikes the ground, and at what time does the arrow reach the maximum height, and what is the maximum height of the arrow, by expressing h t in linear form. Finding 3. Find the speed of the arrow in linear equation and find the distance between archer and the target. Okay. So for the defining the variable, it is given that for the trajectory of the arrow traveled from the archer to the target, we will assume the height of the archer and the height of the target is the same, which is 1.5 meters. Okay, next. So now we'll get to the method of finding. The quadratic equation models an arrow flight in archery by describing its parabolic path, allowing for calculations of factors like the horizontal distance, maximum height, and the maximum time taken of the arrow to reach the target and the ground. So the general form of this equation that we will use is ht plus bt plus c. That is because we will just use the quadratic equation, but we'll give it a twist. We'll put the x into 3 because the x-axis that we'll be using represents the time taken for the arrow to reach the ground or the target. So this is how I represent the parabolic curve of the quadratic equations where the arrow travels in the air, where as you can see, wait, let me zoom in for a bit. As you can see here, it does not touch the curve did not touch the origins, which means this represents the height of the archer, which is 1.5. So we can assume that this point right here is 1.5 because of that, because it represents the height of the archer. While on the other side, we can see that the curve did not touch 4, but theoretically, it will touch the 4 unit when it hit the target. But if it did not, it will hit this point right here. The graph that I just showed you is the trajectory of the arrow when it is expressed in quadratic form. I already gave you the quadratic equation here is negative 5t squared plus 20t plus 1.5, where you can use this equation to find the time taken, the actual time taken for the arrow to reach the target or the ground. So you just put the equation in the equation x plus negative b plus minus set b squared minus 4ac divided by 2a. So you insert the value of a, b, c in the quadratic equation that is stated, which is a is negative 5, b is 20, and c is 1.5. And the result you'll get, you'll get 3 equal negative 0.074 and t is equal to 4.07. But you cannot use the negative value, so we'll just ignore it. This is because, do you know why?
Why can't the time value be negative?
Well, it's a known fact that the negative time just doesn't exist. So there's no like negative 1 hour and so and so. So you can just say that the negative value for time just doesn't exist. So we'll just reject this entirely and we'll use the t equal 4.07. But this value is when your arrow does not hit the target. It hit the ground instead. So if you want to find the value of the time it takes for your arrow to reach the target instead, you'll need to replace your value. You'll need to replace your value for ht is equal to 1.5 because that is the height of the arrow. Okay? So as stated here, t cannot be negative. So the time taken for the arrow to strike the ground, as you can see, I specifically wrote the ground is 4.7. Wait, no, sorry, 4.07. While the time taken for the arrow to strike the target is 4. If you put the value as I stated earlier, that ht is equal to 1.5. So now we'll get to point number 2, is the time taken for arrow to reach the maximum height. We can conclude that the maximum height we can find by finding the axis of symmetry first, because that's the highest point the arrow can reach. So if we look at the graph, earlier, the axis of symmetry lies between here. So the arrow reached the maximum height at 2 seconds, as I showed in the graph earlier, because that's the midpoint. Yes, okay. That's the midpoint, and that's exactly like the axis of symmetry, as you can see. So now this is the maximum height of the arrow if you want to find it in the form of the equation. We'll substitute the value t is equal to 0, and then we'll get the value, the maximum height of the arrow is 21.5 meters. Okay, next. For linear equation, we'll get to number 3 is speed of arrow can be found with linear equation because the speed, as we know, is represented by distance divided by time. Okay, we'll take the quadratic equation that we had earlier, which is ht equal to negative 5 t squared plus 20t plus 1.5, and then we'll divide it by t. This is because I said earlier that speed is equal to distance per time. So when we wrote this, we will get the equation in the form of y equal mx plus c, which then you'll get your value when you find the m is equal to -5, and the c, which is the y-intercept, is equal to 20 plus 1.5 divided by t. And then you'll get the speed of the arrow going is 3.8, or you can write it in decimal places, 0.375 meter per second. So now we'll find the distance between the archer and the target, which we can find it by putting in the equation b squared minus 4ac. As you can see that we substitute the value 0 is equal to -5t squared plus 20t plus 1.5. And the b squared minus 4ac, when we substitute that value, we'll get 413. So the distance between the archer and the target is 430 meters. So now we'll get to the point explaining the reasoning and the analysis of arrows trajectory utilized by two fundamental algebraic model, quadratic equation and the linear equation, to address the distinct aspect of the projectile motions. Go. So now for the quadratic equation, the reasoning. The quadratic equation is essential because it precisely models the vertical motion of a projectile, which it follows the parabolic curve as I stated. It's like ooh. So the parabolic trajectory represents the half of the accelerations due to gravity. So the approximate as g equal 10 meter per second. The negative signs confirm that the parabola opened downward, which is a is less than 0, which means our a value earlier was a negative. So correctly showing the arrow rising, and then it falls down. And the initial height, the constant term 1.5, represents the initial height of the arrow at time t is equal to 0, which we can assume to be the height of the archer, which I said earlier is 1.5 meters. So it does not start from the origins when it comes to when the y is equal to 0, but instead, not y is equal to 0 when the x is equal to 0, but instead it starts at the y is equal to 1.5 because of the height of the archer. So now is the linear equation reasoning, or the quadratic equation governs the vertical motion. The horizontal motion is modeled by a linear relationship. So we can assume that the arrow travels in the constant speed. This is required so that we can determine the speed and horizontal distance that the arrow has traveled. So the speed calculation and the relationship for constant speed can be defined by the formula speed is equal to distance divided by time. So now we'll reach to the conclusions that the problem regarding the archery could be solved by using the implications of quadratic equations and the linear equations. As for the conclusions, we can say that it takes 4 seconds for the arrows from the archer to reach the target when the distance between the archer and the target is, we found it earlier, is 430 meters, and the linear speed of the arrow is 0.375 meter per second. I guess that's it for me. Thank you so much for watching. Bye bye. Okay, thank you.